Hello everyone, this is another ABAQUS tutorial. In this tutorial, I'm going to show you how to model a steel plate shear wall and how to perform a pushover analysis and how to conduct a buckling analysis as well. So this is a steel plate shear wall, mainly have two parts. One is boundary elements and the second is web plate. So the length is 2 meter from center to center and 2 meter height from center to center. The plate thickness is 1 millimeter. The steel material we're using is Q345, which is the yield strength is equal 345 megapascal. The column section is 200, 150, 100. We usually use a very strong column for this kind of structure because the tensile stress in the web plate will transform some force to the boundary elements, especially column, so that causes a very large axial force and moment bending. And the top bottom column beam is 200 by 100 millimeter, so it's less than because we want to the hinge property should inform in the beam, and we use the strong column weak beam principle. Okay, now we go to here. Here is one of I already made one, and I'm going to show you how to conduct such analysis and modeling in ABAQUS. I can go to here. I'm going to first save this one. I call it steel plate shear wall, and I'm going to get a new one and model column. So we can use shear elements, which is mostly used for the steel plate shear wall. You also have choice to use beam elements and also use solid elements. Column, using shell element extrusion and creating a column. This is 150 and this one should be 200, and the length is 202 because we want to use a center to center, so then we have to extend 100 because the 100 in the top, 100 in the bottom, because the 200 is the beam length. And now we're gonna go to the second one. It's called beam. Beam is 100 by 200, so I can go to select this one 100 and this is 200, and the length is from center to center, this is 200, so 100 is reduced and it become 118. And the third one is called web plate. So from center to center is 2000 meter, so 100 from top, 100 both side. The size is become 118 by 118, so I'm going using planar and selecting this one 0 0 and again 118 by 118. Now created the plate. Next we're going to material properties. Using steel Q section, I have this material here and I'm going to add it, and the properties is density is this one, using ton per cube millimeter, elastic 200 or almost 119, and the plastic is here. Next I go to assign the call section. So both column and beam thickness is 10 millimeter. The thickness of both column beam is 10 millimeter, so I can call PC thick thickness shell homogeneous, and I'm going to using 10 millimeter and same material. And the last one is called web. The web plate thickness is 1 millimeter. Here 1 millimeter. So I'm gonna give 1 millimeter thickness. Now I want to assign, this is the web going to 1 millimeter, and beam, and this is beam column thickness, and this is column. So the material is assigned and going to the assembly. So I bring the column first. I'm going to take this one, rotate, and one more rotation in this direction. Okay, now I'm going to select this one. So should be selecting here. I'm going to selecting this point to 0 0. Now you can see it's here, and I'm going to populate this to one more. Now I can give 2000 the length. So this is the center to center. Now bring the beam, and I'm going to first rotate in this direction, and I'm going to select taking this point and bringing to here. And the last one, I want to populate this one more, and it's taking this direction, and it should be 2 meters. And we're gonna delete these ones. So now it's finished, and the last one is we want to bring the waves, and I'm going to take this point and selecting this point and going to put it 8 in this corner. Now the web plate is in the center of the beam column. It's finished. So what I want to do is I want to go to create a partition in this area for the loading part. Going to the part in the column, this is column. I want to go to here and selecting here and this one, this edge, and I'm going to give a line, so that should be 200 millimeter length. So this is it. So we created here one. Let me go to assembly to see where it's exactly in the same place which we expected here. Now what I want to do is I want to merge to consider weld between the boundary elements and the web plates. So I can now call it steel plate shear wall. Now I select all. Now it changed to the single elements. You can go to part and it's C. If you go to the assembly, and it's the material is added that. Now next is going to the step. In the step, the steel plate shear walls need to consider the buckling behavior in the next part, because the steel plate shear wall, we use the buckling or post buckling strength. When you want to consider the post buckling strength, you should do a post buckling analysis and then consider that buckling load to the next stage. So first I want to consider a buckling analysis. I can call it backhoe analysis, and here I should select buckling analysis here, buckling. So I want maximum 3, and you can give a large number to finish that 3 buckling. Next I want to go to interaction. In the interaction I want to create a reference point in this location. Here is the location, and I want to add a reference point here in this point as well. So the next I want to create a set. That set should be the displacement load area. The displacement load, which is equal to the actuator location in a practice or in an experiment. Now what I want to do is I want to create a coupling in this area so that all looks like a support or actuator putting in this location and pushing the structure. So I want to using a coupling and taking this point as a control point and adding this to surface like this. When I push, that means I push in this entire of this area, not just that point, because in that point will provide this convergence. So the next is we go to the load. In the load we create a fixed base for the beam column. You can select here and also here. This is the fixed base, you can call this one. And next we want to create a diaphragm. So for the diaphragm, which the steel material is a flexible and ductile material, so it need a diaphragm. So we want to consider in the top, this floor should have a diaphragm which is supporting a lateral displacement. So we want to create another one. This is called U3. So in this U3 I can select this area and this area and this area and say U3. Now the boundary condition is fixed, so we want to apply a buckling load. So the buckling load we want to apply called BL. So I want to give 1 unit buckling load in this point or in this displacement area. Call this. Okay, now I can go to again and called BL in selecting this point and giving 1 unit. You can give more and the eigenvalue it will be less, so then you can times this load by the eigenvalue and you can get the backline load of this structure. Now the loading is finished, we go to mesh and we want to create a mesh. For the mesh you can use a fine mesh that will give good result. So I'm going to use 50 and then I want to assign the mesh. For the checking, you want to do a checking to see is any problem with mesh or not. So there is no problem in mesh. That's all. So going to the job and creating a job called backhaul. I'm going to submit and submit, and it take a while to finish. It's finished and we want to check the results. So this is the this is the buckling or eigenvalue parameters. You can see it's about 1689. So you can times this to the 1 and it will cause the number of the load that caused to buckle this structure, this plate. So now what we're gonna do is to the next we want to conduct a pushover analysis. So I want to make a copy of this beam, this model here, and I can call it model 2. In the model 2 I want to go to the step and I want to delete the buckling analysis. So don't need buckling analysis in the second one, instead I want to create a static push over, and I want to use the static and giving 100 and giving 10,000 time to incremental time to finish. So I'm going to use 0.1 and minus 15, so that should be the maximum one. Now this is my step time, and I'm going to create a time output from this point here. I'm going to select the set displacement, and I'm going to take the axial force or shear force in this direction, and also the displacement. So that's U1 and or F1. So asking give me every increment. This is finished, and we want to go to the load, and instead of this load I want to create a displacement in that point. So I call displacement. So I can select that point, and I want by 5% of this height of the structure. So it's 2 meter, 5% become 100 millimeter. If in case if you want to see the degradation, the failure, so you can make it to 10%, 200, and it's okay. And I'm going to finished, everything is finished. So one thing is we want to consider the next step of the analysis in the last one. So I'm going to edit, and here I want to create an imperfection. So the imperfection, you should write an imperfection like this: imperfection, give the imperfection, and also you can consider from file, which the file is backl in the previous analysis, and I'm going to show you here backl, and which is equal to step 1, which is taken from the step 1 of this analysis. So now I want to give the mode number is mode number 1, considering 10 times or scale 10 times of that mode, and also third mode 10 times. Okay, and this is finished. I can go to here. This was the backl, which is giving you want to use this analysis. So I'm going to call push over. Now I'm going to submit it. Now it's start to run. The first and second step is starting, and it will take a while to finish. After finish, we will see the result. It's almost finished, 94. It's completed, and I'm going to call a result, and in the result we can see the structure response in 100. So here is the backlink phenomenon, which is creating the structure, and this column is significantly also backled, and a lot of deformation, lots of stress is concentrated here, and here is the column deformation here backled in the area. So now we can go to see the go to here and This was okay, previous one. I'm going to delete it, create that output which we selected, just these two as it is, and here going to operate, combine, and these two, save it, called pushover curve. We can plot, delete it, and this is it. Since in the end of the analysis there is a small deterioration, we can go to check it here, and here is, so the actually it's not deterioration, just a little changes. The structure will not resist to more forces, so if we give a little more displacement, the structure will go to degrade it. So mostly some this area, this connection area, or this beam, this area will fail, and also some other this joint, this column. Okay, this is the end of tutorial. If you have any question, please put in the comment and I will find time to answer you. In the next tutorial, we will conduct a cyclic analysis of this structure. See you next tutorial.